Physics deals with properties of objects that can be quantified. The appropriate use of units is essential to specify the dimensions of those properties with clarity. So let's talk about units. Physics is a science that deals with properties of objects and the relationships among them. For those relationships to be established, the properties involved must be measurable or able to be calculated from other measurements. A property that can be measured or calculated is called a physical quantity, and to be expressed unambiguously, we need to specify its magnitude and units. As an example, the mass of an apple could be specified as 0.10 kilograms, where 0.10 is the magnitude of the mass, and kilograms is the unit we are using as reference. Specifying the units is essential because the amount of mass of the apple would have a different magnitude if other units were used. For example, 0.22 pounds in the units used widely in the USA. Along history, different cultures have established different units. Thus, for example, in England and the USA, the use of the imperial or English system of units is common, which uses the second to measure time, the inch to measure length, and pounds to measure mass. Whereas in most other countries, the metric system is used, which uses meters to measure length and kilograms to measure mass. To establish a uniform system of units that facilitates collaboration, the international scientific community has defined the International System of Units. This system defines 7 base units: second as the unit of time, meter as the unit of length, kilogram as the unit of mass, Kelvin as the unit of temperature, ampere as the unit of electric current, mole as a unit of amount of substance, and candela as a unit of light intensity. All physical quantities can be expressed as one of those base units or as a combination of them. The derived units are a combination of the base units. For example, speed, which is defined as distance divided by time, has units of meters divided by seconds. On the other hand, density is defined as mass divided by volume and has units of kilograms divided by cubic meters, where cubic meters are the units of volume. We often need to convert a quantity from one system of units to another. To perform a unit conversion, we need first the equivalence between the units to be converted. For example, 1 mile is equivalent to 1,609 meters, or 1 pound is equivalent to 0.4536 kilograms, or 1 day is equivalent to 86,400 seconds. With adequate equivalence of units, we can write a conversion factor that can be used to perform conversion of units. A conversion factor is the ratio of two values that represent the same physical quantities. For example, since 1 mile is equivalent to 1,609 meters, the ratio of 1 mile over 1,609 meters is a conversion factor. Since the values at the top and the bottom of the ratio represent the same physical quantity, the ratio must be identical to 1. Note that before you can actually perform the division, you must first convert the miles to meters or the meters to miles, and that is how the ratio equals 1. Since conversion factors have a value of 1, multiplying a quantity by a conversion factor will not modify the physical quantity represented. Let's see how to perform a conversion of units using conversion factors. Let's say that you want to convert a distance of 71 miles into meters. We know that 1 mile is equivalent to 1,609 meters, so we can write the conversion factor as 1,609 meters divided by 1 mile. Note that we choose to put the miles at the bottom so that the miles of the conversion factor will cancel the miles of the original units. After we multiply 71 by 1,609 and divide the result by 1, we get 110,000 meters. The units of miles of the original quantity have cancelled with the units of miles in the conversion factor. Let's now solve a problem that is a little bit more elaborated. We have the density of steel, which is 0.283 pounds per cubic inch, and we would like to convert it to kilograms per cubic meters. So we start writing the given quantity, and after that we write the conversion factors that we need to get the desired units. So we start by converting the pounds into kilograms. We know that 1 pound is equal to 0.4536 kilograms. So we will write the ratio of these two quantities, and we will put the pounds at the bottom so that the units of pounds in the original quantity cancels the unit of pounds in the conversion factor. Next, we write the conversion factor for the cubic inches. In this case, we will put the units of inches at the top because we want to cancel with the units of inches at the bottom of the original quantity. Now, we have to note that the inches are cubed, so the conversion factor must be cubed as well. Otherwise, the cubic inches will not cancel with the inches in the conversion factor. So the pounds units cancel, the cubic inches cancel, and after we multiply 0.283 times 0.4536 and divide by 0.0254 cubed, we get the result. So the only units that survive are kilograms divided by meters cubed. And this is the desired density in kilograms per cubic meters.